50 years after the beginning of space exploration, we still don't understand what's heating the solar corona and accelerating the solar wind up to really high speeds.
So there's this long-standing mystery: how do you create a hot corona from a cold star?
And by going in very, very close to the sun, we're learning about the sources of energetic particles, where they begin, right down in the solar atmosphere or corona.
The solar corona is the upper atmosphere of the sun. That's millions of degrees. It's very hot. Whereas the photosphere, the white light sun that you see in the sky, is cool. And so the idea of Solar Probe is to actually go there into the corona and make the measurements that are behind the plasma physics phenomena.
The Parker Solar Probe is getting so close to the sun that it will answer questions that we can't even formulate right now.
My hope is that with Solar Probe, we're finally going to get close enough to the sun we can directly measure the solar wind in the corona.
If you're trying to study the source of a waterfall, understand the origins of a waterfall, but you're at the bottom of it and all you see is this mixed up, turbulent mess, it's really hard to understand what's happening at the top of the waterfall. And that's what we're doing now. We're getting closer and closer to the top. I think we're on the cusp of being able to answer the question of what heats the solar wind.
Figure out what physics is actually responsible for these high temperatures and the acceleration of the wind to these supersonic speeds.
WSPR has already seen some things that are giving us hints into some of the long-standing predictions of what we might see.
The instrument is working really well, and the results are very surprising.
I'm really excited that we're learning about the space radiation environment.
We now measure the magnetic field, the structure of the magnetic field. We're measuring the dynamics of the magnetic field.
We're seeing lots and lots of these small-scale eruptions from the sun.
It's very important for understanding how humans can travel or not travel out through the solar system.
So what we learned from Solar Probe will definitely play very seriously into our understanding of space weather, of the dynamics of the Earth's magnetic field, currents around the Earth that are driven by the sun itself.
It's also very important for protecting satellites in space.
So to see this data, it's just a pleasure. I mean, the data is so spectacular. It's really terrific stuff.